In this video, we will solve the numericals of Henry's law constant. Henry's law. So numerical number 1 is the Henry law constant, that is Kh, for oxygen dissolved in water is 4.34 into 10 to the power 4 atm at 25 degrees Celsius, and partial pressure of oxygen is 0.2 atm under same condition. So while solving the question, you must remember, you first write the values given. The Kh is 4.34 into 10 to the power 4 atm, and pressure of O2 is 0.2 atm. You need to calculate mole fraction of oxygen first, and the question is asking calculate the concentration of oxygen. That means you need to calculate molality of oxygen. So first we will apply the formula, that P is equal to Kh into X. X of O2 will be P upon Kh. So P is 0.2 upon 4.34 into 10 to the power 4. It is coming 4.6 into 10 to the power minus 6. This is the mole fraction of oxygen, which is very less. So we have formula, mole fraction is equal to moles of oxygen upon moles of oxygen plus moles of water. So moles of oxygen upon moles of oxygen plus water. Since mole fraction of oxygen is 4.6 into 10 to the power minus 6, which is very less than mole fraction of water, because XA plus XB is equal to 1. If A is very less, then V will be very high, and some of these should be 1. So here mole fraction of oxygen is 4.6 into 10 to the power minus 6 is equal to moles of oxygen you need to calculate. From denominator, this value is left out. Moles of oxygen will be left out. And for moles of water, let mass of water is equal to 1000 gram, because it is not given. Its molecular weight is 18. So its number of moles will be 1000 by 18, that is equal to 55.55. On substituting this value in the denominator, that is in moles of water, the 4.6 into 10 to the power minus 6 is equal to moles of O2 upon 55.55. It is giving moles of O2 is equal to 4.6 into 10 to the power minus 6 into 55.55, and it gives the answer 2.5 into 10 to the power minus 4. These are the moles of oxygen coming. After solving the moles of oxygen, we will apply the formula molality is equal to moles of solute upon mass of solvent in kg, which we let 1000 gram. 1000 gram means 1 kg. So moles of oxygen are 2.5 into 10 to the power minus 4 upon 1. So this is the answer, mole per kg. After solving this question, we will come to Next question. The next question is, find the mole fraction of oxygen in a saturated solution of oxygen in water at 298 Kelvin when partial pressure of O2 above water is 0.2 atm, 0.21 atm, 0.21 atm. Calculate, and we have already written that find the mole fraction of water. You need to calculate mole fraction of water here, and it has the value of kh 2.3 into 10 to the power 5 atm. So we have the formula P is equal to kh into x. Need to calculate x. So x is equal to P upon kh. P is 0.21 atm upon, this is 0.21 atm. kh is 2.3 into 10 to the power 5 atm. Atm got cancelled. So it means it will become unitless. After solving this one, you will have the answer 0.91 into 10 to the power minus 6. These are the mole fractions of oxygen. So this question is a direct question. That mole fraction is being asked, and partial pressure of oxygen above water is given and value of kh is given. After writing these value and substituting this value in the direct formula, we will have the exact answer 0.91 into 10 to the power minus 6. Now question number 3. If N2 is bubbled through water at 293 Kelvin, then how many millimoles of N2 gas would dissolve in 1 liter of water? Here partial pressure of N2 is 0.987 bar and kh is 76480 bar. So this is in bar. 1 atm pressure has the value 0.987 in bar. Now we will write the formula P is equal to kh into x, where we will calculate kh. Kh is equal to, that x is equal to kh upon P, which is 76480 upon 0.987. 0.987. No, that x is equal to P upon kh. X is equal to, once again we are going to solve. There was a mistake in the formula, that x is equal to P upon kh. P is, your partial pressure of nitrogen is 0.987 bar, which is equal to 1 atmosphere. But we will not put 1 atmosphere, we will put in bar because kh value is also in bar. which is 76480. So bar will get cancelled. To give the value 1.29 into 10 to the power minus 5. This is the mole fraction of nitrogen. Now, because we have taken 1 liter water, so volume of water is equal to 1 liter, that is 1000 ml. Mass will also be 1000 gram because density of water is 1 gram per ml. So that's why 1 ml of water is equal to 1 gram. So 1000 ml will be equal to 1000 gram. So mass of water now is 1000 gram. Its molecular weight is 18. So its number of moles will be equal to 1000 by 18, that is equal to 55.55. Then we will calculate the mole, that number of moles of oxygen, the nitrogen. So here mole fraction of N2 is equal to moles of N2 upon moles of N2 plus moles of water. We have calculated that mole fraction of N2 was coming 1.29 into 10 to the power minus 5. Since we know XA plus XB equal to 1, mole fraction of nitrogen is 1.29 10 to the power minus 5, which is very less than that of moles of water. So we will leave this denominator value. Then we will calculate the moles of nitrogen by multiplying 55.55 with the mole fraction of water. So X of N2 will be now N of N2 upon N of water. Then 1.29 10 to the power minus 5 is equal to moles of N2 upon 55.55. So N of N2 will come 7.16 into 10 to the power minus 4. These are the moles. Now millimoles of nitrogen. The question is asking millimoles of nitrogen. 1 mole is equal to that 1000 millimole. So here 7.16 into 10 to the power minus 4 into 10 to the power 3. In this way, the answer is coming 0.716 millimoles. Once again, we are going to revive the question. The question was to find the number of millimoles of nitrogen which is dissolved in water. The value of partial pressure of nitrogen is 0.987 bar and the value of KH is 76480 bar. We know that P is equal to KH into X. P is equal to KH into S. Then we put the formula X is equal to P upon KH. The mole fraction of nitrogen is coming 1.29 10 per minus 5, which is very less than that of water, mole fraction of water. So we will remove the moles of nitrogen from the denominator of mole fraction. Then the exact mole fraction will be N of N2 upon N of water. Number of moles of water will be 55.55 gram because we had 1 liter of water and 1 liter of water will be equal to 1 kg, that is equal to your 1000 gram. Reason because the density of water is 1 gram per ml, that is 1 ml of water is equal to 1 gram. Therefore, the number of moles of water are coming 55.55, which will get multiplied with the mole fraction of nitrogen to give the value 7.16 into 10 power minus 4 moles, which is multiplied by 10 to the power 3, 1000 to get the number of millimoles.